Okay. Question number 7. Here we're looking at separable first-order differential equations, and the definition is that a separable first-order differential equation can be written in the form, I don't know why I put 3 equal signs there, is written in the form dy dx equals a function of both x and y, where you can break this function of x and y up into a product of x, a function of x, and a function of y. In order to solve a separable ODE, you want to isolate the variables. You want to get the dy together with the function of y, and you want to get the dx together with the function of x, and then integrate both sides of the equation, and if you can, solve for y. So here we're given a separable differential equation. Notice that I have a function of y, y to the 1/2, times a function of x, x plus 1. And we're also given an initial value problem. We're given an initial value so that once we solve this equation, we'll be able to solve for that constant of integration. So our goal here is to take our differential equation and get the y terms on one side of the equation, I'm going to do that by multiplying both sides of the equation by y to the negative 1/2 power. That way this y to the 1/2 and the y to the negative 1/2, when you multiply them, they'll give you y to the 0 power. Y to the 0 power is 1. It'll cancel out the y on the right side. And I'll also multiply both sides by dx to get that dx out of the denominator on the left side. Cancels there. Here the y's to the negative, y's to the powers cancel, and it's going to leave me with y to the negative 1/2 dy equals 1 plus x dx. Okay, now we can solve the equation by integrating both sides. When you integrate both sides, you only need one constant of integration. On the left side of the equation, this is just y to the negative 1/2. When you integrate, just increase the power by 1. That'll give you a positive 1/2 as a power, and then divide by 1/2, which is the same as multiplying by 2. And I'll put my constant of integration on the right side. The right side, when I integrate 1 plus x, I'm going to get x plus x squared over 2, and then plus the constant of integration. So can I solve for y? I think I can. Let's go ahead and solve for y. I'm going to first get rid of that 2 by multiplying everything in the equation by 1/2. That's going to give me y to the 1/2 equals 1/2 x plus 1/2 times 1/2 is 1/4. 1/4 x squared plus c over 2. And then to get rid of this 1/2, you can square both sides. And I'll bring that up here. When you square both sides of the equation, you get y is equal to 1/2 x plus 1/4 x squared plus c over 2 squared. Okay, now let's solve for c. We can use the fact that y of 0 is equal to 1. Y of 0 is equal to 1. That tells me to put 0 in for every one of these x terms, and it's going to cancel out the 1/2 x, it's going to cancel out the 1/4 x squared, and it's going to leave me with just c over 2 inside parentheses squared. That gives me 1 is equal to c squared over 4. Multiply both sides by 4 to get 4 is equal to c squared. Then when you solve for c, you get c is equal to plus or minus the square root of 4, which is 2. C is equal to plus or minus 2, and we can choose the positive one because up here we've got the square root of 2. We want I think if we chose the negative one, it's going to put us below the y-axis, and we need our initial condition to be above the y-axis. At negative 2 we're going to be subtracting 1, and for small values of x, that'll put us with, well, I don't know. But I'm going to choose a positive value and substitute it into this equation to get y equals 1/2 x plus 1/4 x squared plus c as 2. 2 over 2 is 1 squared. And that's my solution. I think if I would have substituted into an earlier equation before I squared it, if I would have substituted y of 0 equals 1 into this equation, it would have ended up being positive. See, if y is 1 and x is 0, you're going to get 1 is equal to c over 2. Multiply both sides by 2 and you get c is equal to 2. The positive 2, not the negative 2. The negative 2 comes from squaring both sides here, which sometimes gives you extraneous solutions. So here's our answer.